Hello, everyone. This is Jehad. I'm a chemistry PhD student at Clarkson University. My research addresses the eutrophication through phosphate sensing and adsorption. Now, let me share the screen to walk you through my current project for phosphate adsorption. So this project focuses on upcycling waste printed papers into an efficient adsorbent for phosphate removal from water. So what if a single molecule is both essential for life and a potential environmental threat? This molecule is phosphate. It's indispensable for human and animals as it supports the skeletal health, the energy transfer, the DNA synthesis, and the growth. And in plants, it is vital for photosynthesis, energy transfer, and plant development. For this reason, farmers commonly use it as a fertilizer to enhance the growth of their crops. It also plays a vital role in detergent industry. It serves as a chelating agent, binding calcium and magnesium to prevent water hardness issue and enhance cleaning efficiency. However, if phosphate present in excess in the water with a concentration higher than 25 part per billion as phosphorus, it boosts the growth of algae blooms in a phenomenon known as eutrophication. Eutrophication decreases the dissolved oxygen levels, decline the biodiversity, and decrease the water quality. And this has economical consequences, such as increase the cost for water treatment, adverse effects on seafood industry, and a decline in tourism returns. It has been reported that $2.4 billion are spent annually in the US alone to address eutrophication. So it's really important to ensure the sustainability of phosphate and food while decreasing its environmental impact. To achieve this, we need technologies that sensitively determine the concentration of phosphate in the water. We also need technologies that selectively capture phosphate from the water. And this is what I will be focusing on in this video. Now, the question is, can the printed papers that people threw away every day become the solution for eutrophication? In my research, I proved it can. So I upcycle waste printed papers into an efficient adsorbent for phosphate capture from the water through the extraction of cellulose. So cellulose is a biodegradable material that is rich in OH functional group that facilitate its chemical modification, which is the second step in our approach. So we functionalize cellulose to enhance its affinity for phosphate capture from the water. Our last step will be testing the potential of the phosphate-loaded material as a slow-release fertilizer. This can close the loop of phosphorus, help providing solution for eutrophication, and decrease the waste printed papers in the landfill. That's all for today. Thank you for your attention.